Hello everybody, today I'm going to talk about area of composite figures. So let's first talk about what a composite figure is. A composite figure is a figure that can be separated into, let's call them regions. Okay, and these regions, these are basic shapes, like triangles, circles, squares, rectangles. What else did we have? We had trapezoids and parallelograms. To find the area of a composite figure, what you're going to do is you are going to divide up the regions. So you're going to take that figure and divide it up into, I should write into regions. So you want to divide it up into regions or shapes that you are familiar with how to find the area of. And you're going to find the area of each region. And then you're going to take all of those areas. You're going to add up all the areas. Okay, so let's take a look at the first example here. So for the first example here, you can see, I'm going to outline it for you, that you have a rectangle. There's one shape. And then you also have a trapezoid. Okay, and the way that we find a area, whoops, that's not an area of a rectangle is we do the length times the width. And the way that we find the area of a trapezoid is 1/2 times base 1 plus base 2 times the height. So for this problem here, let's look at the rectangle first. That one's pretty easy to do. Plugging it in, the area of the rectangle is going to be 12 times 23. So doing 12 times 23, I get 276. Okay, so you can, if you want to, you can do area of rectangle like that, or what some people, so to distinguish the difference between your different areas, different ways that you can do this, a lot of people like to label, like, this is area region 1, this is region 2, so this is going to be area 1. Let's do area of region 2, and that is of the trapezoid. The base 1, 15, plus, now this is base 2, and since it's congruent to the other side of the rectangle, we know it's 23. And then the height of the trapezoid goes from one of the bases to the other. So it's got to be this length right here. Now we don't know that length, but we know that from here, this is 12, and they tell us over here on the other side, so this is 12, and they tell us that the whole length is 18. So then the height of your trapezoid is going to be 6. 6 times 1/2 is 3. 15 plus 23 is 38. Makes it a little bit easier. 38 times, what was it, 3? 114. So then what you're going to do is you're going to take those two areas and you're going to add them together. So the total area is going to be 276 plus 114. So I already have that in there. So 390. And since it is area, it's always units squared. So that's your final answer. So it's pretty easy once you figure out how to break the shape up and talk about what kind of shape it is. It's pretty easy to do these problems. Let's look at a second example. In the second example, here I have half of a circle. Here I also have half of a circle. In the middle, I have a parallelogram, like that. There it is. Okay, so here we'll call this region 1. And then these two circles, half circles, are actually congruent. They would make a complete circle. And the reason why I know that is because from this center, right here, to the outside, that is 6 inches. So that means from the center to the other side also has to be 6. Okay, which means that whole thing has to be 12. In a parallelogram, opposite sides are congruent. So if this is 12, this is 12. And this is the center of a circle, so this has to be 6. And this has to be 6. So they are equal. So you can think of these together as one circle. We'll call it area number 2. So we're going to consider these to be one circle. Okay, so the way that we're going to find the area of region 1 for the parallelogram, it's just base, which is 12, times the height, which they gave us here, is 5. So the area of the parallelogram region 1 is just 60. And then the area of region 2, which is our circle, represented by pi r squared. Okay, r is 6, so it's pi times 6 squared, which is 36 times pi. Putting that into my calculator, pi times 36, 113.1. And then all you have to do is add those two areas together to get your total. 60 plus 113.1. So my answer is 173.1, and what is it? Inches squared. Area is always units squared. So these next two examples, I'm going to talk about them just so you can get an understanding of how you would do them, but I'm not going to do the whole problem. But I will give you the final answer so you at least know what the final answer is going to be. In number 3, I would break it up into 3 regions. I have my half circle here. Okay, I have a triangle here. And then, last but not least, this is a rectangle. Okay, so we know that we'll call this area 1, we'll call this area 2, call this area 3. Okay, So what you would have to do is you would have to find the area of the rectangle, area of the triangle, and area of the circle. And they have given you all the information that you need. Okay, so they have said that this portion here is 7, right? And they have also told us this is 9, so that means that this has to be 9. And since that is a diameter of a circle, that means this has to be 9 also, which means that from here to here, guess what that would be? It would also be 9. Now the reason we want to know that, let me remove that 3 out of the way. We would know that this was 9. I'll rewrite that 3 for you here. Okay, so the reason why we want to know that this is 9 is so that we can figure out what this portion of the triangle is. Okay, so this portion is 7, this portion here is 9, the whole from here to here they tell us is 26. So you have to do 26, oops, if I could do this correctly, 26 minus 7 minus 9, which is 10. So that's what that would be. The reason you need to know that is because you have to know the height of the triangle. Okay, now for the area of region 1, it's just length times width. For the area of region 2, it's 1/2 base times height. In the area of region 3, is we know that the area of a circle is pi r squared, but this is only half of a circle. So if you're going to do half of a circle, it's 1/2. And that's because it's a half circle, or we could call it a semicircle. Okay, so you would find the area of each one of those, and then your area total is going to be 325.23 feet squared. I'm not going to go through all the work of plugging in all the numbers. If you'd like to try this on your own, press pause, give it a try, and see if this is what you get. If you're not sure what happened, feel free to leave a comment on the assignment in Google Classroom, and I'll be happy to help you. Some other examples here to go through. Number 4 is interesting because you do have this half circle here as one of your regions. I know it looks like a little ice cream cone here. So I do have, for region 1 here, I have the area of a half circle. So a circle is pi r squared. So that means it's going to be 1/2 pi squared. Now remember, they've given you the diameter here. So in this problem here, to get the value of r, you would have to break that diameter in half. So the radius would be 8. Okay? And then for the triangle, this is an equilateral triangle, not equilateral, an isosceles triangle. They don't give us the height. Okay, so we need to know what this height is in order to find the area of this triangle. Okay, so because this is your base, 16, your height, we don't know it. So in order to find the height, this is a right triangle, you're going to have to use Pythagorean theorem. Okay, h happens to be a leg, so you're going to do h squared plus 8 squared equals 17 squared. So in going through that work, you'll be able to find the value of h, which then will allow you to find the area of my second region, which is that big triangle. So the area, 1/2 base times height, the height you're going to have to find, and the value of b is this diameter of the half circle. So your b value is going to be 16. So the area for the total is going to be 220.53 meters squared. So you can complete the rest of the work on the Pythagorean theorem to find the height and plug in the values to see if you can get that. Okay, On the last example here, you're going to have 3 regions. Again, you're going to, in this triangle region over here, you're going to have to do Pythagorean theorem. And the reason you're going to have to do that is because you don't know the base of the triangle. So you'll have to do Pythagorean theorem to get this value here, right? And then you'll have to find the area of this triangle. They give you the height, so this is going to be your h. What they don't give you is the base. For the triangle, your base is going to be your value of x times 2, because the base of this triangle is this whole thing. So you'll use Pythagorean theorem on just this part here to find the base, and then you would double it to find the whole base of the bigger triangle. Okay? Or you can find the area of the half triangle and just double it, right? There's that too. But you are going to have 3 regions. So region, it doesn't really matter. Region 1 could be this, region 2, then region 3, right? And then adding those all together, this is a good one to try on your own. You're going to get 410.68 meters squared. So give that one a try on your own and see if you can get it. Okay, so I hope you like this video, and if you have questions about the practice, please make sure that you ask in the comments. You can, and for my students, please ask your questions in Google Classroom. So here is, again, composite figures, and good luck with your practice.